Good afternoon, good evening, good morning, depending on the zone where you are now. All right, it's M.Saidi with the predictions of grade 11 physical science. What do you expect to find in your paper? And let's discuss about this. We expect you to get 100% because this paper, you must kill it. You must kill it. I think when I say you must kill it, you understand what I mean. Don't forget to like, to share for others so that they can also join the live. If you have any challenge when I'm trying to discuss some concepts, please let me know. Get a paper and then you write down what I'm going to tell you. At least you must go to the paper so that you don't miss out. Number one. This paper is chemistry. I know that chemistry is a problem to people, but let's not waste time. We're going to try to focus on those concepts which are going to be a challenge to you and you are able to get a distinction. You need to know the following. Number one, what you call a chemical bond. A chemical bond. Because what you're going to be dealing with is going to be bonds. So at least you must know what do you mean by a chemical bond. Don't forget that whenever you talk about a bond, you're talking about attractions. Yes, the force of attraction between different atoms. So please go to the paper when you know the definition for a chemical bond. Some things I'm going to explain them so that you don't get lost, but things related to definitions, please go when you know. Number two, you need to know what we call, when you are drawing, what you call the Lewis diagrams. I'm going to give you examples, what you are supposed to draw. Ne? Yes, so you have to know what you call the Lewis. When you say Lewis, sometimes you call them Lewis dot diagrams. Why? Because they are in form of dots. So Lewis diagrams. I'm going to give you the elements and how do we manipulate them so that you get. You need to know what you call the valence electrons. Let me give you an example. You must use a periodic table. Ne? Let me give you this example. I will show you. Those questions, we're going to do them. So let's take an example of carbon. Here is carbon. Yes. Carbon is in which group? We know that carbon is found in group 4. Yes, it's 14, but we don't count these transition elements, so it is group 4. So when you are writing, it means that if it is found in group 4, it means that it has how many electrons outside? Basically, if you draw the structure of carbon, you'll find out that it has 4 electrons. So the valence electron will indicate the number of the valence will show the group number. So when you use a group, for example, nitrogen is group 7, it means that the outermost shell, using the octet rule, it has 7 electrons. When you go to oxygen, it has 8 electrons. When you go to fluorine or fluoride, it has 9. You see? So, did I say 9? Not 9. It has 7 because it is found in group 7. Oxygen, it has 6. Nitrogen, it has 5. And then carbon, it has... So you have to know, when they say valence electron, you must know. Yes? Yes. Why am I saying this? Because you have to apply what I'm going to show you, what you are supposed to draw. When the paper comes, what you are supposed to draw. Yes. Then... So I'm going to explain these diagrams just with the examples, with the questions I've set for you. So I'm just now doing the highlight. After that, I show you the questions and then we deal with those questions so that at least you go when you are stable. Then you have to know how to explain what you call the electrostatic forces. And these electrostatic forces, in terms of energy, why? If you look at carbon, atoms, no, not carbon, hydrogen atoms, and also helium. why is, a question can come like this and ask you that, why is hydrogen can exist as this, yes, hydrogen, and then helium doesn't exist like that? Hydrogen can exist as 2, while, take note of this question, while helium exists like this. It doesn't exist like this. Why? So what is happening here? You have to know the reason. But let me just give you a simple explanation for this. Hydrogen is found in group 1. Sometimes we say it's group 1, sometimes we say it's group 7, whatever, depending on the periodic table. So we say that it is group 1. Why? Because it has 1 electron in its outermost shell. Don't forget that we said that the valence electron will show the group number. So it is found in group 1 because it has 1 electron in its outermost shell. You understand? So don't forget that when using the octet rule, the first shell must have 2 electrons. The second, third, whatever, up to the number, it must have 8. 1, 2, 3, 4, 5, 6, 7, 8. But this first one must have 2. So hydrogen, it has only 1. So it is only remaining with 1 electron to be full. While helium, yes, helium has 2 electrons. It's already full. It means that it doesn't require another partner for it to bond. While hydrogen will require, it has 1 hydrogen, it has 1 electron. So it will require another hydrogen, yes, so that these 2 electrons can form a bond. Don't forget that the bond is formed by 2 electrons. So that now, if I draw the structure of hydrogen, 1 electron, and another hydrogen with another electron, meaning that now this first shell is having 2 electrons, therefore it's full. But helium, it is already having 2 electrons, meaning that it doesn't require any assistant. It doesn't require to borrow any electron. It doesn't require to lose any electron, meaning that that's why it is able to remain as helium like this, while hydrogen, it requires another atom of hydrogen so that it has 2 electrons in its outermost shell. So that for it to be stable, it will require 1 electron from 1 hydrogen and another electron from another hydrogen so that it forms this bond. I think I'm clear there. Yes. So go when you know why is hydrogen, yes, forms this diatomic molecule, while the helium only has 1 atom. Yes. So please, I think I've explained because of the electron, the number of electrons outside. So we're going to look at some of the questions there so that you see it clearly. Yes. The next question is, oh, sorry for that. Please, guys, if you have any challenge when I'm trying to show you, please let me know, because you didn't show me that something is not happening. So basically, this is what I was trying to explain, that you have to know what a chemical bond, Lewis diagram, and then I explain you a question that say that why is helium forms? It forms, helium forms this, while hydrogen forms this. It has 2 atoms, while helium has 1 atom. I explained it, and then I say that helium is in group, check, if you come here, you'll see that helium is in group 2. Sorry, it is in group 8. Yes. So if it is in group 8, it is a noble gas, meaning that if you look at it here, helium, yes, it has 2 electrons in outermost shell, while hydrogen has 1 electron. To be stable, you're supposed to have 2 electrons in the first shell. So hydrogen has only 1 electron. So what it's supposed to do is supposed to have another hydrogen with another electron so that these 2 can share, and then you form something like this. So this is a hydrogen and this is also hydrogen. So they have these two electrons. So the bond can be there, can be formed so that you form a diatomic molecule. While helium, because it is already stable, it doesn't require any other assistant. So therefore, it is only having one atom, just like this. You can't find helium like this. No. I think I'm clear there. Then we go to the next question. We go to the next question where we are saying that what you are supposed to look at. The interpretation of the graph. You need to do the interpretation of the graph. The graph of the distance and the potential energy. I know that this is a challenge to some of the people. Yes? So let's try to do the interpretation. So you have this graph. Yes? Let me show you. You have this graph. Guys, don't go to the paper without knowing this graph. Ne? You have this graph. Let me draw it like this so that you see it clearly. You have two atoms. These two atoms, they are far apart, A and B, whereby the intermolecular force of attraction between this and this, they are too weak, meaning that if this is 0, below 0 is negative. So it means that here you're going to have negative values, but above 0 is going to be positive. Yes, positive. So if this is 0, 2, 4, 6, 8, 10. So guys, I'm explaining this. I have questions I'm going to give you so that I'm explaining this so that you don't just memorize. Yes. So that now what is going to happen is, if these two, what is happening with, if this is the distance, this is the distance. Yes. So it means that this distance becomes the bond length, while this one is the potential energy. So meaning that this is the energy for at a particular point of these atoms. So now what happens if these are like this? It means that the energy is too small. So as they keep on coming, meaning that now the distance have shortened, they have come like this. The distance is now too small. It means that you have what you call the attraction and the repulsion. Attraction and the repulsion. So the attraction, what is going to happen to the attraction? The attraction is going to increase as these atoms are coming together. So when you go down, when they come too close, the attraction is going to outweigh. Now when it's like this, the attraction is too much compared to the repulsion. When I explain this, I always give examples to students that, for example, you have an appointment with someone you love. Yes, can be your father, can be your mother. But when it's 2 hours to the meeting point, you don't feel it that much. This is the attraction and the repulsion. But now when it's just 1 hour, yes, you feel the attractions. Yeah, you're about to, you start to get that attraction between that person you are going to meet and you understand? So the attraction keeps on increasing. Now when it's time for you to meet, now the person is in front of you. That is the maximum attraction you can have. But now what happens when this person comes and they start touching you? Some people, they get irritated when they start touching, meaning that this atom and this atom, now the distance is too close in such a way that the repulsion now starts to outweigh the attraction. The moment the repulsion starts to outweigh the attraction, now the energy increases. That's why here you see that it's like that. So this distance between these two atoms is what is the distance. This distance can be quoted by this. We say that is x. This distance from here to here, that distance is what called the bond length. While this energy, because they say this is potential energy, while this energy you quote here is what called the potential energy. Don't go to the paper without knowing this. You regret. If you don't understand, let me know. Ne? let me know so that I clear it. I clear it up. So let's go to the next point. I'm just highlighting so that I give you the questions which we are going to deal with. Then you're saying that go when you know, at least when to know, define what you call a covalent bond. What is a covalent bond? Don't forget that when you talk about a covalent bond is a type of attraction between atoms whereby electrons are being shared between these atoms. For example, this covalent bond is most we always find it in non-metals. Yes, for example, chloride and a chloride. So because a chloride is a non-metal and another chloride is a non-metal, the type of bond which is formed here, we call it covalent bond. Carbon and hydrogen, non-metal, we call it covalent bond. But this type of bond is formed as a result of sharing. I think I'm clear there. It's as a result of what? Sharing of these electrons. So we're gonna see that clearly. So when you talk about sharing, let me give you examples here. Carbon is in group 4. Carbon is in group 4. So I want to form this. Carbon is in group 4. So it means that it has 4 electrons. This is what I'm saying. Carbon is in group 4. You see, group 4. Yes. And then hydrogen is in group 1. Meaning that to form this structure, I'm going to have carbon, which is in group 4, meaning that it has 4 electrons. 1, 2, 3, 4. But I have 4 hydrogens. So hydrogen has this, meaning that it has 1 electron outside. Meaning that these electrons, 4 of this, 1 is going to come there, 1 is going to go there, another atom going to go there, and then another atom is going to go there. So at the end of the day, I'm going to have 1 carbon and then 1 hydrogen. 1 carbon and 1 hydrogen, 1 carbon and 1 hydrogen there, 1 carbon and 1 hydrogen. Meaning that this carbon, the first electron is shared with 1 hydrogen, another one with another hydrogen, another one with another hydrogen, another one with another hydrogen. That's why I have 1 carbon, hydrogen, 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 hydrogen. This type of bonding, because there is sharing, it's not transfer of electron, we call it covalent bonding. So you have to know that before you go to the paper, so that you are able to draw the Lewis dot diagram. Let's go to the Lewis diagrams. And then this is where the most marks are going to come from. Can I repeat? This is where the most marks are going to come from. I think you understand what I'm saying. So, yeah. So what I'm saying that is, this is where the most of the marks are going to come from. So now let's go to examples of these diagrams which you are supposed to draw so that you are able to get these marks. I'm just going to be very fast so that now you are able to draw, do some questions I've prepared for you. Draw the Lewis diagram of hydrogen. This one is simple. Hydrogen, which group? You go to the group, find hydrogen is there. How many electrons? So it means that hydrogen is 1 electron. How many do I have? 2 carbons, you see, meaning that 2 hydrogens. It means I use 2, meaning that I have 2 electrons. So when you're drawing the Lewis diagram, it means that hydrogen, yes, how many electrons? It has 1 electron, yes, and then another hydrogen, it has another 1 electron, meaning that this is going to combine with this, meaning that I'm going to have another hydrogen, so that when they combine, you form 1 hydrogen there and another hydrogen brings another electron. So this is the type of bond. Yes, this is the bond. So it becomes like that, simple like that. So at least you have to know how to draw the Lewis diagram of hydrogen, fluoride, water. Yes, I'm going to talk about the water, I'm going to talk about the ammonia, and then I'm going to talk about the additive bonding. Yeah, because that is what is going to cost you a lot of marks. Okay, water is going to be is formed like this, the Lewis diagram of that. Okay, so this is going to be hydrogen is in group 1, so it's going to have 1 electron, while oxygen is in group what? Check here, you come here, oxygen is here. Don't take this number, you take the group what? Group 6. So it means that hydrogen is going to have 1 electron, oxygen is going to have 6 electrons. Why? Because we say that it is found in group 6. You see, group 6 here. Yes, so the group will show you the valence number of electrons. But how many hydrogen do I have? I have 2, so that times 2, meaning that I have 2 plus 2, making it 8. So when I'm drawing the Lewis diagram, I must have 8 electrons, 6 from oxygen and 2 from hydrogen, meaning that I'm going to have oxygen. Yes, the oxygen is going to have how many electrons? It's going to have 1. First distribute them equally, 2, 3, 4. Then after 4, you start now to pair them. 5, yes, 6. But hydrogen, there are 2 of them, but each hydrogen is having 1, meaning that I'm going to have a hydrogen here, and I'm going to have a hydrogen there. You see? So meaning that I have 2 lone pairs. The 2 electrons which are not involved in the bonding, but they are found in the outermost shell. Those are what we call the lone pairs. So meaning that, and this will help us to know which type of shape is this water having. You understand? Because it has lone pairs, so it means that, check, when I draw, check, is going to form that. So this is the diagram. But now, when they ask you the shape, it means that it's going to be this, like this, with the 2 electrons, yes, and a hydrogen here, and a hydrogen there. You see? Meaning that you have 1 electron here, and 1 electron there, 1 electron there, and 1 electron there. 1 from hydrogen, 1 from oxygen. So it forms that V, which we call the bent shape. We call it bent shape, or we can call it angular. Or you can say bent. So you must know the shape which water has. So when you know the Lewis diagram of water, the shape of water molecule, then number 2, you must know how does water forms a additive bond. So what is a additive bond? A additive bond is formed when one atom brings the 2 bonding electrons in that bond. You understand? For example, now we have seen that water is like this. Water is like this. Yeah, is like that. So when you are talking about additive bond, it means that I'm going to add another hydrogen. Yes, this hydrogen is a positively charged, meaning that it has lost the electron already. So since it is a positively charged, it means that it doesn't have an electron. So it means that the bond which is going to form here is going to come from water molecule. You understand? So it means that when I combine these 2, yes, what is going to happen? Is that when I combine these 2, it means that I'm going to have the water molecule here. This is the oxygen. I'm going to have the hydrogen here, meaning that is going to form 2, and then another, yes, then plus the one which we have added. But this bond, these electrons, they are going to come from This one has not brought anything. Because now, this has given out one electron to this so that it forms a bond. So it's going to become, it has remained with this electron. So it means that and that. So it's going to become, what is it going to become? It's going to become positively charged because it has given out one electron to this. You understand? So it has become positively charged. That hence, how do you call this? We call it hydrozonium ion. Or sometimes we can call it acidic water. Hydrozonium ion. Yes. Yes, if you have a challenge, let me know. Let me know. Which topic are you doing? Prepared. Okay. This one is saying that, which topic am I doing? Molecular structure. Yes. Then they are saying that we go to the next question. If they can also bring for you what you call ammonia. It's the same, what you call dative bonding, whereby the two electrons which are involved in the bond are being shared from one atom, or they are being supplied by one atom. The other one doesn't come with anything. Ammonia, I know that many students, they don't know how to read this. It's called ammonia. Yes, some people, they say nitrogen trihydrogen. That's wrong. It's called ammonia. This ammonia, when it adds a hydrogen, you form what we call ammonium ion. But how does this ammonium ion form? This is formed by what you call additive bond. Additive bond. Let me show you how this ammonia forms this additive bond. So you have ammonia. You have nitrogen. Nitrogen is in which group? Nitrogen is in which group? They are telling you here is in group 5. It means that it has 5 electrons. 1, 2, 3, 4. Then I put a 5 there. But now, hydrogen is in which group? Hydrogen is in group 1. Yes, it means that it has only 1 electron. Meaning that I have 3 of them. So when I combine the 3 of hydrogen, so what's going to happen is going to form this ammonia. Meaning that I'm going to have nitrogen and a hydrogen there. Okay. Nitrogen and a hydrogen there. Okay. Nitrogen and a hydrogen there. Cool. So it forms this ammonia. But now, to form a dative bonding, I repeat, dative bonding, it means that I'm going to add this with this. But remember, I've used 1, 2, 3. It means that I'm remaining with these 2 lone pairs. So when I add a hydrogen, this hydrogen has no electron. Check. It's a positively charged. Has no electron. It means that the bond, the electrons which are going to be formed, used in the bonding, are going to come from one atom, which is nitrogen. Hence, I'm going to form nitrogen, yes, hydrogen down, hydrogen that side, hydrogen that side. But these are electrons, don't forget. Yes. And then the remaining electron, this one, yes, is going to come from, the one which is going to combine with this is going to come from nitrogen. Therefore, I'm going to have something like that. And at the end of the day, because nitrogen has given out 1 electron to this hydrogen, therefore, I'm going to form a positively charged. I'm going to form a positively charged. Hence, you form that structure. I think I'm clear there. Yes. The next question you are going to find in your paper, if you are a grade 11 student, I'm going to show you grade 12, and I'm also going to show you grade 10. All right. They're saying that what you need to know is other shapes. when you talk about other shapes, so we have seen that how do we call which type of shape does water form, which type of shape does chloride methane form, and which type of shape does ammonia form. So we have said it. We say this is called ammonia, this is called water, and then this is called methane. Yes, so you have to know this. You have to know that this is. So which shape does this form? Which shape does this form using the Lewis diagram? Yes. So you have to find out now, for example, nitrogen. Yes. This one is nitrogen. Nitrogen, does it have a lone pair? Yes. If it has a lone pair, what does it? It means that its nitrogen is in group 5. So it's 1, 2, 3, 4, and then 5. Meaning that here I'm going to have hydrogen because there are 3 of them. Hydrogen, hydrogen. You understand? So because of the repulsion which is expected from this side, and it must have the biggest angle, therefore this structure is just going to tilt just a bit. When it tilts a bit, it's going to form, so it pushes this hydrogen down because of this strong intermolecular force, this strong intra molecular force of attraction, the one which are found inside the atom. So it means it pushes it a little bit down, and once it pushes, it means that this one, it is, let me show you exactly what you, yeah, it pushes just a bit up like that, and then what happens here, it forms, which shape is formed here? It forms what you call the trigonal pyramidal. Trigonal pyramidal. So how is this trigonal pyramidal formed? Let me show you. Why do you say that is a trigonal? It means that it must have a triangle. If you join this, it forms a triangle. You see, trigon, but it has a pyramid on top. You see, it forms that pyramid, and another one that side. You see, it forms a pyramid, but down it forms a triangle. So we call it, because it is down, trigonal, and then on top it becomes pyramidal. Hence trigonal. For ammonia, because of the lone pairs, it forms trigonal pyramidal. If I have another one down, a pyramid down, yes, then it forms trigonal bipyramidal. I think I'm clear there. Yes. I'm not explaining that in detail. I'm just trying to show you. Please, I repeat, don't go without knowing the shape of ammonia, the shape of water, and the shape of methane. How do I form a additive bond with ammonia? And how do I form a additive bond with the water? I think I'm clear there. Then, let's go to the next part. How do you calculate electronegativity? How do I calculate electronegativity? And how do I know that this is a polar bond, this is an unpolar bond? So now once we go there, we have to talk about calculations. It means that here I'm going to show you how do we do that. You have to know calculation for electronegativity. Don't go without knowing it. Electronegativity, and then polar, a polar bond, and then polar molecule. because you can have polar bonds, but the molecule is not polar. For example, you can have carbon and chloride. These two, because this one has a different electronegativity from this, it is going to be polar bond. But because I have C trichloromethane chloride, like that, this bond is polar. This bond is polar, this bond is polar, this bond is polar, but the whole molecule is not polar. Why? Because the force from this side and the force from this side, they cancel. Force from this side and force from this side, they cancel. Therefore, it leaves the electronegativity in this molecule to be 0. Hence, we shall say that the molecule is not polar, but the bonds between the molecules are polar. Hence, you have to know what we call the polar bond and the polar molecule. How does a polar bond lead to a polar molecule, and how is a polar bond? One molecule can be polar the bond can be polar while the molecule is not polar. What brings about that is electronegativity. The attraction force between the bonding pair of electrons. The ability of these atoms to pull the bonding pair of electrons towards itself. You and your father, your mother and your father, who loves money most? Let me know in the comment. The one who loves money most, it means that he has a high affinity for money, has the electronegativity for this money is too high, so it pulls the money towards themselves. You understand? However, the money the mother has taken is going to help the family. Even the father is going to benefit, because the mother is going to go and buy something and then brings it in the home, meaning that however much this bonding pair has been pulled to one atom, still they will benefit the molecule. For example, I gave you a chloride, so they are supposed to be shared equally. But because now this one has a higher, let me show you, because I'm just talking, and then look here. How do I get this figure? You check on the periodic table. Check. Here they say that this is electronegativity. So if you look at chlorine, what is electronegativity of chlorine is 3. What is electronegativity of carbon is 2.5. It means that chlorine is going to pull this bonding pair of electrons toward itself compared to carbon. Carbon doesn't have that amount of energy to pull it. Therefore, this is going to change, and then I'm going to have the bonding pair of electron towards that side instead of being this. Now, this one is going to become partially, because as obtained electron, partially negative, and then this one is going to become partially positive. We call it half negative, half positive. And then because now we have a different pole, negative and different pole, negative, therefore we shall say that this bond is polar. Polar comes from the word pole. I think I should have maximum classes with this. Yeah, let me know in the comment. Yes, if I should have maximum classes for physical science grade 11. This is nothing. You have to understand this concept. Yes. All right, let's go. So please don't go without knowing electronegativity, polarity, and the bond polarity, and then molecular polarity. So how do I calculate the electronegativity of a bond? So let me just use the same thing, carbon and chloride. So I will go and look for chloride. We said chloride is 3. So it means that is 3.0 minus the carbon. Carbon is 2.5. And then it means that the polarity of this is 0.5. So that is how you are supposed to calculate the polarity. Yes. Let's go to what you expect. So bond energy, bond length, I've talked about them using the graph, and then the relationship. You must explain the relationship. Make sure that you go to the paper when you know this graph. You make a mistake without knowing it, you are gone. All right, let's go to the next question. Now the type of forces: van der Waals forces, then London force. Okay, the van der Waals forces, which we call the dipole, London force, hydrogen bond, ionic dipole. So let me just generalize the London force. London force, you have London force. Yes, you have dipole. You have hydrogen bond. Guys, London force are weak. Dipole are stronger than London forces, but hydrogen bonds are stronger than dipole. You have to know that. So a compound which has a hydrogen bond will have a higher boiling point. It will have a higher boiling point. It will have a higher melting point. You have to know that. So let me show you the different questions. Other things I'll talk about them. Let's do these questions. Define what is a chemical bond. When someone says what is a chemical bond, what do you say? What is a chemical bond? Yes, don't forget that I told you that a chemical bond, it must be a force of attraction between the what? Between the molecules. You understand? So what I was saying that when you say that what is a chemical bond, we say that is a force of attraction. It must be a force of attraction, yes, between atoms, or it can be between the molecules or between the ions, so that they form the molecule. Force of attraction between two different atoms. It can be atoms. It can be what? Atoms. It can be what? It can be ions. So draw the Lewis diagram of, yes, draw the Lewis diagram of, okay, let's see how we're gonna draw the Lewis diagram of hydrogen cyanide. Hydrogen, this is called hydrogen cyanide. Cn is called the cyanide. So let's draw the Lewis diagram, hydrogen cyanide. So when it says hydrogen cyanide, okay, you come here, you say that hydrogen is 1, yes, it has 1 electron. Carbon is in group 4, it has 4 electrons. And then nitrogen is in which group? Nitrogen is in which group? Is in group 5, yes, if you check the periodic table, meaning that it has 5 electrons. So in its outermost shell. So when you are now drawing, it means that you have carbon, yes, the carbon is supposed to have 1, 2, 3, 4, isn't it? Yes. Now you have hydrogen is only 1, so that one is sorted. What about nitrogen? Nitrogen is having, okay, we said is having 5. It's 1, 2, 3, 4, 5. But now there is something unique here. What you need to see, I have 3 electrons which are free. I also have 3 electrons which are free. It means that this electron and this will combine, this electron and this combine, this electron and this will combine, meaning that I'm gonna have I'm gonna have hydrogen, yes, it's gonna form that bond with the carbon, so that one is sorted. But now this and this is gonna form a bond, so I'm gonna form a bond there with the nitrogen. This and this is gonna form another bond. Are you seeing? Yes, and then this and this is gonna form another bond. You see? But now it has these 2 electrons which are remaining. So basically, this nitrogen will have a lone pair and 3 bonds and 1 bond from this side, so that when I count the bonds is 1, 2, 3, 4. So meaning that the real structure is going to look like hydrogen, carbon, nitrogen. You understand? So because I'm gonna have here 1 bond, yes, you see, and then this one and that, then 2 electrons which are there. So the structure is gonna look like that. In other words, the actual structure looks like that. You understand? Because sometimes don't show that, but this is a real structure. So in actual sense, the real structure looks like that. So that's what they are looking for. What about water? I've talked about water. Draw the Lewis diagram of water or structure. I said that don't go without knowing ammonia, or don't go without knowing water molecule. So that one was very clear. And then I keep emphasizing that please don't go without knowing that. So this is water. Let me see. Water is equal to oxygen is in group what? Oxygen is in group 6. And then hydrogen is in group 1, but I have 2 times 2, so meaning that 2 of them. So the electrons I'm supposed to use, they are supposed to be 8. So I'll draw this, say it's 1, it's 2, it's 3, it's 4. You understand? And then now 4 is 5, it's 6. But hydrogen, it has another one, and then another one, meaning that it forms a structure like that, which we call the bent shape. What is the shape of hydrogen cyanide? Which shape are you going to form here? The shape you're gonna form here, because this one is not going to push anything, so it's going to be linear. The shape which is going to form is gonna be linear, meaning that it's straight. It's gonna form a straight. Check here, it's gonna be like that. But don't forget that for water, it's gonna form a V shape or angular. We call it angular. Calculate the electronegativity difference between the cyanide bond. The cyanide bond. Cyanide bond. So now, what is electronegativity here? What is electronegativity here? Basically, they are saying calculate the electronegativity difference for the cyanide bond. They're not saying cyanide bonds, ne? They're not saying cyanide bonds. So if they are cyanide, don't forget that it forms 3 of them. So 1 bond is equal to what? So you go to nitrogen, you go to nitrogen, nitrogen is what? We say this is nitrogen is 3. This is 3. And then carbon is what? Carbon is 2.5. Is 2.5. Yes. So carbon is 2.5, and then hydrogen. So if you are calculating 3 of them, so it means that because I have 3, meaning that I'm going to multiply the answer you get. Okay. Here is going to be 3 minus 2.5, which gives me 0.5. But because there are 3 of them, yes, if there are 3 of them, if they ask you cyanide bonds, then you multiply it by 3. But because they didn't talk about that, so it's just going to be, the answer is going to be 0.5. Yes. But because if they said bonds, then you would have said this, then it becomes 1.5. Am I clear? Cyanide, 1 bond is equal to 0.5. What about the 3 of them? If it's like this, 3 of them, then it's going to become 1.5 by multiplying it by 3. Yes. So please don't go without knowing electronegativity of a molecule. What is the polarity of hydrogen cyanide molecule? Right only polar or non-polar? We want to know. But how will you know that is polar or non-polar if you don't know how to calculate electronegativity? Guys, don't go to the paper without knowing how to calculate electronegativity. hydrogen cyanide. Don't forget that hydrogen is what? Come here and see. Hydrogen here is what? Is 2. You see? Hydrogen is 2. So if this is 2.1 and then carbon here is 2.5. So when I subtract here, it's gonna be 2.5, yes, minus 2.1, which gives me 0.4. Yes, cool. What about now? This is gonna be, we said that the answer is 0.5, but it has 3 bonds, meaning that this side, these 3 bonds is gonna have 1.5, meaning that this 1.5 is not equal to 0.4. If they were equal, then it would have been non-polar because the difference is 0. But because now there is a difference, even if it is 1 bond still, because there is a difference, then automatically it's gonna have what? It's gonna have 0.1 as a difference. Still, it's gonna become polar. However much even polarity we have, either it's weak polar or is ionic polar, or so it depends on the kind of polarity which is there, but it's gonna be polar. So the answer here is supposed to be where am I? The answer, what type of yes, is gonna be polar. Give a reason. Yes, because of the difference in electronegativity. The table below indicates the value of bond length and the bond energy of different bond in hydrogen cyanide. Yes. Hydrogen cyanide, here you have this. Explain why bond energy of hydrogen cyanide is more than the bond energy of hydrogen and carbon. Why is the bond energy of this is more than the bond energy of this? Don't forget that see their triple bonds, while this one is a single bond. You have the factors which affect the bond, the type of bond which is formed. We say that the more the bonds, the stronger the intermolecular forces of attraction between them. So it means that since I have a lot of bonds here, it means that this one is going to be stronger than this. If the bond is if the bonds are more, the shorter it's going to be, and the stronger the what? The bonds. So here, this one, there are more bonds. It's going to become short a bit, and then it's going to become stronger. This one is 1 bond. It means that it's a little bit longer, and then it becomes weaker. Hence, the bond energy for this is going to be higher than the bond energy here. Please don't go without knowing that. Okay. Explain the difference between bond length. I think I've explained it. Explain the difference between bond length of hydrogen cyanide and the bond length of, yes. Explain the bond energy. So the bond energy, we have talked about it. It means that it is strong. Why? Because of the what? Because of the multiple. It has multiple bonds. Hydrogen cyanides have multiple bonds. Had 3 bonds, while this one has a single bond. Now, when they say explain the difference between bond length and bond energy, bond length bond length of this and the bond length of this. So it is gonna bring back to you that this bond length and the bond length here, the bond length here is C, but it's one is a single bond, while this one bond length is a triple bond. Don't forget we say that the more bonds you have, the shorter is gonna be. The fewer bonds you have between atoms, the longer is gonna be. It means that single bond is longer than, yes, a double bond, which double bond is longer than a triple bond. So this one, if in this scenario, this one is short, stronger. This one is longer compared to this one. You understand? But this one is not longer than this. Why? Because this is a single bond. So single bond, long and weak. Multiple bond, short and strong. I think I'm clear there. Yes. Will hydrogen cyanide be soluble in water? Right, yes or no? It can only be soluble if it is polar. Why? Because it's gonna form the bond with the hydrogen atoms or with the molecules of the water. You understand? So because we have seen that this is a polar molecule, therefore it's gonna be soluble in water. Am I clear, guys? Yes. Then we go to the next question. Lebu, are you here? Let's go to the next question. The next question is saying that explain the answer. So we have said it's referring to the polarity. So we have said it that it forms the electronegativity of this of hydrogen and carbon is lower than the electronegativity of carbon and nitrogen. You understand? Making the molecule to become polar. Hence, there will be an intermolecular force of attraction between this molecule and the water molecule. Yes, and the water molecule. Hence, it's going to become soluble. Define electronegativity. We have talked about it. Electronegativity is the ability of the atom to pull the bonding pair of electron. Draw the Lewis diagram of oxygen difluoride. Oxygen, when you say oxygen difluoride is oxygen, but fluoride is a di. So now we have done this. Make sure that you know how to do oxygen is 1, 2, 3, 4, then 5, 6. Isn't it? Yes. And then fluoride is going to have 1. Remember, it has 7 of them. Yes. So one of it is going to come here. 1, 2, 3. It's going to be like that. And then now I have another one here. It's going to have a bond there. And then you saturate it with the electrons. So it's going to look like that. Then they're saying that the calculate the electronegativity difference between oxygen and fluoride in, yes, they are saying that oxygen and fluoride, in oxygen difluoride, and predict the polarity of the bond. Yes. We have to go and find out which type of fluoride. Oxygen, where is oxygen? Oxygen is 3.5. What about fluoride? Fluoride is 0.5. Therefore, it's going to be polar, meaning that 4. So here the answer is gonna be 4 minus 3.5, isn't it? Yeah, it's 3.5. Oxygen. Yeah, it's 3.5, while fluoride is 4. So meaning that the answer here is gonna be 0.4. So what does that figure indicate? What does it indicate to you? You have to know what does that figure indicate to you. So we go to the next question. They're saying that explain the statement referring to this and this molecule in your explanation. Include the polarity of the bond and the shape of the molecule. So explain the statement by referring, yes, this and this. So here now you come and what you need to do here is to draw the structure and then find out. Okay, this is the oxygen. We saw it. Let me draw it like this. So basically it's gonna be yeah, because it has lone pairs. It has lone pairs. It's like that, né? So fluoride is gonna be there, sorry, and then a fluoride. So basically it's gonna be what? It's gonna be a bent, or what you call angular, while this one is gonna be carbon, 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 and then oxygen. So it's a double bond, meaning that oxygen that side, yeah, so it meaning that it's gonna be oxygen, yeah, it's gonna be like this. This is linear, it has no lone pairs, you understand? It has no lone pairs, while these ones are going to have lone pairs. So because of this, the force this side and the force this side is the same, so it means that it's going to form, this one is going to be what? It's going to be non-polar. However much the bonds between the molecule is polar, this one is going to form a polar molecule because of the shape. Is a bent shape, angular. So if it was straight, then it would have formed what we call, yes, it would also have been it would have been non-polar, but because of the shape, then it becomes polar. Then they're saying that diagram below represent the energy change that takes place when two atoms move towards each other. So it means that as they are far apart, they come closer, they have reached the maximum distance, and then now when it goes up now, the distance is too close in such a way that the repulsion force, here the repulsion force is greater than the attraction force, yes. Here the attraction force is greater than the repulsion force, yes. Here the force of attraction and repulsion is almost zero. Here the attraction increasing, outweighing the repulsion. Can I repeat? Here we are saying that the force of attraction and repulsion is almost zero. Here the force of attraction is increasing, outweighing the force of repulsion. Here the force of attraction is greater than the force of repulsion. But now here the force of attraction, the force of repulsion is greater than the force of attraction. That's why the energy now increases. And then now this from here, this distance from here to here is called the bond length, while the energy you caught, because this is energy, yes, the energy you caught here, yes, is what you call the bond energy. So we can bring figures and ask you which one is the bond energy, which one is the bond length. This is the bond length, and then this is the bond energy. This is the bond energy you caught here, and then what you caught here is the bond length, because here they are saying the distance of the two nuclei. What does X represent? Define the concept X. Where is X? Yeah, this energy. So they're asking you to define what is the bond energy. So basically a bond energy is the amount of energy which is released when you break the bond or you form the bond. Yes, the amount of energy when you're forming the bond or you are breaking the bond, it becomes what you call the bond energy. Yes, so you have to know that. Guys, don't go to the paper without knowing that. Then we go to the next question. It's about boiling point, melting point. So this topic is also coming, boiling point, melting point. All right, but the boiling point, melting point, it must be related to the intermolecular forces of attraction. As I explained that, guys, don't go without knowing London forces. Don't go without knowing a dipole. Don't go without knowing hydrogen bond. So I'll give you what you call the bonus. You must remind me about the bonus of the paper. All right, they're saying that refer to the intermolecular forces, explain the difference between boiling point and the boiling point of ammonia. This is called ammonia. I've taught you how to read this. Ammonia and nitrogen. The intermolecular forces of attraction between this and this. So if you come here, you see that ammonia, it forms this, while this one forms this. Which one has a higher boiling point? Which one has a higher boiling point? The one which has a higher boiling point is the one which has a lower figure, because these are negatives. So basically, we said that hydrogen bonds are stronger than dipole-dipole. And dipole-dipole are stronger than London force. So hydrogen bond can only form when there is a hydrogen and a highly electronegative element or atom. So when you look at nitrogen and nitrogen, yes, nitrogen and nitrogen, which kind of, can this one be hydrogen bond? No, because we don't have hydrogen bonds there. We don't have hydrogen there. So it cannot be hydrogen bond. What about when I have, so this one becomes dipole. But the actual type of dipole, we can say that it's an induced dipole. So then what about this ammonia? Ammonia, nitrogen is too electronegative. Yes, and then it has a hydrogen now. You see, it has a hydrogen. So nitrogen is like this. Now it has a hydrogen. It means that this one is going to be much of electropositive and much of electronegative. Therefore, this one is going to become a hydrogen bond. It's going to form a hydrogen bond. Hence, the boiling point of ammonia is going to be higher than the boiling point of nitrogen. Hence, they are saying that refer to the intermolecular force of attraction in the boiling point. So they can bring water here and maybe nitrogen. Which one is going to have a higher boiling point? Water. Why? Because it has hydrogen bond. What about nitrogen? It has dipole-dipole. Hence, we expect to have we expect to have a higher boiling point here compared to this. I think I'm clear there. Then they're saying that write down the formula of the substance in the table that will have the lowest boiling point, the lowest melting point. If it has the lowest boiling point, then it will have the lowest melting point. So the melting point, the one which has the lowest melting point, is going to be hydrogen, because it has the lowest boiling point. Explain why hydrogen will evaporate faster than this. It's because of the intermolecular forces of attraction. This one is the type of intermolecular forces of attraction which are involved here is the London force or London depressions. So it's weak, and then this one is going to have dipole. Therefore, this one is going to have a lower boiling point compared to this. Hence, we are saying that hydrogen will evaporate faster because its boiling point is low. Its boiling point is what? Is low. Explain why hydrogen, yes, faster than this. Refer to the intermolecular forces of, or the strength of the intermolecular forces of attraction. Then the next question is saying that write down the formula of the substance in the table that will have the highest vapor pressure. The highest. The one which will have the highest vapor pressure is the one which will have the lowest boiling point. Low boiling point is equal to high vapor pressure, and low vapor pressure will equal to high boiling point, meaning that this thing is inversely proportional. The higher the boiling point, the lower the vapor pressure, and the lower the boiling point, the higher the vapor pressure. Write down the formula of the substance in the table that will have the highest vapor pressure and explain your answer. The highest is this one, you see? hydrogen. Why? Because it has the lowest boiling point. Therefore, the intermolecular forces of attraction are easily broken and then it evaporates, hence forming a high vapor pressure. Yes. Then we go to the next question. I think it's the last question, guys. They're saying that reaction, write down the reaction of methane. Yes. Define the covalent bond. What's a covalent bond? We said it, that is the type of bond which involves the sharing of electrons between two the atoms. Then draw the Lewis diagrams of this. We have drawn the Lewis diagrams. I think even if I don't repeat this, guys, make sure that you go when you know how to draw these Lewis diagrams. How many lone pair of electrons? Define lone pairs. We said that these are pair of electrons which are found in the valence shell, or the type of the electron pairs, electrons which are found in the valence shell, and they are not involved in the bonding. They are supposed to be pairs, but they are not involved in the bonding, so we call them lone pairs. They're just lonely there. They're saying how many lone pair of electrons are on the central atom of carbon dioxide molecule. So we have to draw the structure of carbon dioxide. Is carbon 1, 2, 3, 4, because it's found in group 4, while oxygen is in group 6, meaning that it has 1, 2, 3, 4, 5, 6. The same story here. 1, 2, 3, 4, 5, 6. It means that now what is going to happen here? This is going to combine with that to form a bond. This is going to combine with that to form a bond. This is going to combine with that to form a bond. And then this is going to combine with that to form a bond. So this is the central atom. Did they say the central atom? It means that it's going to leave carbon, 2 bonds. And then 2 lone pairs there. 2 lone pairs there. Carbon, we don't have any lone pair. So the answer here is going to become 0. Nothing. Identify the one substance in reaction 2 that can form a additive bond. It must be either ammonia or water. So in this case, it's water. So the answer is water. I explained and I showed you how this water forms a additive bond. I think I was clear here. I showed you here. You see how it forms that additive bond. Guys, don't go to the paper. I repeat, don't go to the paper without knowing a additive bond. When I was doing a prediction for grade 11, I did the summary, and then most of the people were not watching the video until the end, and then they ended up losing it. When they came out of the paper, they said that, sir, what you predicted is not the one. Say, okay, let's go and open. When I showed them, say, yo, I don't want you to be like that, ne? Yeah. Because everything which I said, it came. All right, let's go to the next question. Guys, make sure that if you have missed something, make sure that you watch the video. You watch it until you go to the paper. Make sure that you do all these questions. You will kill it. So they are saying that write down the shape of water. Identify one substance in the reaction. We have said is the answer here is water. Then they are saying that write down the shape of water molecule. So we have said write down the shape. The shape here, we said that it forms a bent shape like this. It forms that shape. Yes, it's a bent, or sometimes you say angular. And then carbon dioxide is a linear shape. Although molecules of methane and the chloromethane, yes, chloromethane have same shape. Yes, methane is a nonpolar while chloromethane is a polar. Give a reason for your answer. It's because of this. It's because of the chloride. Yes, it has a different electronegativity, meaning that it will bring about a difference. So the electronegativity of the chloride will show, and then you will end up will bring about the electronegativity to be not zero, not to be zero. Hence, this one is going to become polar, and then this one is going to become non-polar, because when you subtract the forces is going to go to zero. Well, if you subtract this is a chloride, this is a hydrogen, hydrogen, this and this won't give you zero. Hence, it's going to become polar. I think I'm going to stop here for today. Make sure that you go through what I've discussed. I repeat, so that you don't regret for your marks. Let me know if you have any question. If you have any question, drop it in the description box there, so that I can deal with that question. I will say thank you very much by joining our class. See you in, please upload this. Okay, I'm going to upload, so that at least you can go through these questions. Yes, I'm going to upload it, and then I'll send you a link in the description, so that you can go through those questions, and those things which I've not included in the questions, please make sure that you discuss them. Thank you very much. Yes, as life as bus, ne? Thank you, ne? Yeah, for reminding me.